So in this video, we're going to talk about the chain rule. The chain rule is used when we need to take the derivative of something that is made of a composition of functions. For example, if we have to take the derivative of sine of x squared, really what we have there is a composition of two functions. The first function being the sine of x, the second function being the x squared. So the chain rule states that if f is differentiable at the point u, where u equals g of x and g is differentiable at x, then the composite function f of g of x is going to be differentiable at x, and that f of g prime is going to be f prime of g times g prime of x. Really what that means is that if we have y equals f of u and then u is some other function g of x, then the way we take the derivative of y with respect to x is by taking the derivative of y with respect to u times the derivative of u with respect to x. So let's use this simple example right here where we have f of x is equal to the sine of x squared. And really this is the same thing as saying that y equals the sine of x squared. So let's just say, for example, here that we let u equal x squared. So really what we have now is y is equal to the sine of u. And the way we're going to take the derivative of y with respect to x, the way we find dy dx, is going to be to take the derivative of y with respect to u times the derivative of u with respect to x. So I know y is equal to the sine of u. That means that I know dy du is simply going to equal the cosine of u. And I know u is equal to x squared, so the derivative of u with respect to x is simply going to be 2x. So now that I want to go back and say, okay, the derivative of y with respect to x, I have to take dy du times du dx. So that's simply going to be y prime, or in other words dy dx. We'll stick with that notation. Dy dx is going to equal the cosine of u times 2x. And if we think back to the beginning, remember I know that u is really x squared, so if I want to put this back into in terms of x, I can simply say that dy dx is going to equal 2x times the cosine of x squared. Okay, so really what we're saying now is that this function here, y, is changing, the derivative is changing not only as the sign changes, but as the x squared inside the sign changes. So really we have two different functions here, the first being, again, the sine of x, the second being the x squared. So let's look at this as another example in this case here, where in fact we're going to have actually a three-link chain. We don't simply just have the cosine of x, we don't simply just have a square root of something, we have three functions here actually. The first, the innermost function, we're going to call u. So u is going to be my innermost function, which in this case is going to be x squared minus 3. Okay, and then so I could write this f of x as the square root of the cosine of u. The second innermost function is going to be the cosine. So I'm going to let v equal the cosine of u. So another way that I could write this now is I could say that y is equal to the square root of v. So really v is the cosine of u, where u is going to be x squared minus 3. So I basically just simplified this out a little bit through some substitution here, and we could even change this a little bit further if we want to say v to the 1/2. So again, the way that we're going to find the derivative with respect to x, if I want to find dy dx, is I'm going to have to take the derivative of y with respect to v times the derivative of v with respect to u times the derivative of u with respect to x. Okay, and taking each one of those individually isn't so bad. So let's start with dy dv. I know that dy dv is going to be 1/2 times v to the negative 1/2, which is the same thing as 1 over 2 root v. I know that I can take dv du, and the derivative of the cosine of u is going to be the negative sine of u. Okay? And lastly, I can take du dx, and that's simply going to be 2x. So again, the way I go back and I find dy dx is that's the product of dy dv, dv du, and du dx. So I'm going to say that dy dx, the derivative of y with respect to x, is going to be the product of 1 over 2 root v times the negative sine of u times 2x. Okay, and if I simplify that a little bit, I'm going to get negative 2x sine u over 2 root v. And I know the 2's will cancel there, and I can replace the u and I can replace the v. And so I'm going to get a negative x times the sine, and I know u was x squared minus 3. And I know v was really the cosine of u. And again, I know what u is. U is up here. It's the x squared minus 3. So I can substitute one more time and say that we get a negative x times the sine of x squared minus 3, all of that over the square root of the cosine of x squared minus 3. Okay, so really what we found now is if we take the derivative of this right here, it's not just one function that's changing. It's really three composite functions that are all interchanging together. So we have this x squared minus 3, we have the cosine of the x squared minus 3, and then we have the square root of that whole thing. So we have to take the derivative of each one, multiply them together, and the derivative would be this here, this negative x times the sine of x squared minus 3 over the square root of the cosine of x squared minus 3. We're going to do one more example of the chain rule, but we're going to do it in the context of a slightly bigger problem. So this one here would be requiring the chain rule. So I know that y is equal to the sine of x squared minus 5 times the cosine of x cubed. If I want to take the derivative of this, I need the product rule. Okay, so if we're going to find the derivative of y with respect to x, the product rule says we're going to do the first term, which is the sine of x squared minus 5 times the derivative with respect to x of the cosine of x cubed plus the second term, which is the cosine of x cubed, times the derivative with respect to x of the first term, which is the sine of x squared minus 5. So in this case here, we're actually going to use the chain rule twice. We're going to use it once to deal with the derivative of the cosine of x cubed, and we're going to deal it once to deal with the derivative of sine of x squared minus 5. So we're going to use the chain rule at two different times here. So let's start first with the cosine of x cubed. The basic rule, anytime you're applying the chain rule, it's the derivative of the inside times the derivative of the outside. All right, so whether we use that u substitution or we kind of think of what's actually happening, it's really always going to be the derivative of the inside times the derivative of the outside. So in this case here, I would have let u equal that x cubed, and so we get the derivative of the inside, which would be 3x squared, times the derivative of the outside, which would have been a negative sine of x cubed. Okay? And so this here is the derivative of the cosine of x cubed. So that's actually going to get multiplied by this sine of x squared minus 5 right there. And we're going to do the same thing right here. We're going to have to take the derivative of the sine of x squared minus 5. So again, that's going to be the derivative of the inside times the derivative of the outside. So the derivative of the inside is going to be 2x, and then the derivative of the sine is the cosine of x squared minus 5. Okay, and again, that there is going to get multiplied by this cosine of x cubed. So now if we're going to take these and kind of plug them back into the this long formula here to see what we have, we can now say that dy dx is equal to the sine of x squared minus 5 times 3x squared times a negative sine of x cubed plus the cosine of x cubed times 2x times the cosine of x squared minus 5. And if we kind of just rearrange a little bit to maybe simplify it, make it look a little bit more natural, we would get dy dx is equal to, I'm just going to take my negative sign of my 3x squared out front, so 3x, or negative 3x squared times the sine of x squared minus 5 times the sine of x cubed. And I'll do the same thing over here. I'll pull that 2x out front, so we'll say plus 2x times the cosine of x cubed times the cosine of x squared minus 5. Okay, so you can see, the chain rule can make things complicated in a hurry, because sometimes, you have a function hidden inside a function hidden inside a function, and that can complicate things very, very quickly. The best thing you can do is to keep your work organized. Remember that the general rule is always the derivative of the inside times the derivative of the outside. And if you end up with one of those 3-link or 4-link chains, like we see in example 2, the more you can keep your work organized, the more you can kind of use this substitution, the better off you're going to be. I would always recommend writing out this step here, where you're going to show the plan with how you're actually going to find dy dx. If you can kind of make that plan for yourself, then finding the derivative itself becomes a lot easier. I know we didn't write it out in this case here, but again, that's going to be the general form every single time. All right, I hope this video helps. The best advice I can give you with the chain rule is to keep practicing. Good luck, and I'll see you in the next video.